And general seekers of truth. In this video, we will continue solving some problems dealing with areas and using some knowledge of algebra. So we have here a parallelogram whose base is 3 times its height, and we're given the area and we want to find the length of the base and the height. So as usual, for any geometry problem where it's kind of wordy, we want to express the information that we have here geometrically as a picture as much as we can. So I'm going to sketch this picture out as best I can. So here's my parallelogram, and I know that it has a base that's a bit longer than its height. Now don't forget that the height is the length that is perpendicular to the base and passing through one of the other vertices. So this horizontal length here is our base, and this vertical dotted line here is our height. And we know that the area of a parallelogram is simply the base multiplied by the height. And we know that the area here is equal to 136. So we can set up information and fill it in as best we can. Now we also know an extra piece of information that the base is 3 times its height. In other words, B is equal to 3h. So we can take this information about the base and substitute it in to our equation for the area. And let me show you how this is done. So we have 136 is equal to the base, but instead of the base, we're going to have 3h multiplied by h. So that gives us 136 equals 3 times h. Now once again, let me remind you, 3 times h is h squared times 3. And again, we typically are tempted to take the square root immediately, and that could work, but it's quite messy. So it's easier to divide by 3 first. So if I divide 136 by 3, I don't know what that is at this point, but so I'm just going to leave this as 136 over 3 is equal to h. And then now would be a good time to take the, that would be equal to h squared. I'm getting ahead of myself now. Now we can take the square root of both sides. And that gives me square root of 136 over 3 is equal to h. And then I'm going to use my calculator to figure out what this approximation is. Alright, so this is about 6.733 is approximately equal to h. And if I multiply that number by 3, I get 20.199. And that will give me the base. So 6.733 is the height, and 20.199 is the base. And there you have it. Another example of using information in the problem to write 2 equations, performing substitution, and then solving for a variable. Now we will continue with yet another example, but a slightly more complicated one. So here we have an equilateral triangle. One length of an equilateral triangle is 16. Find its area. Okay. So this will be a little bit trickier. Here I have a equilateral triangle. Draw it out this way. Okay, and I'm going to draw it as best I can. So that's my equilateral triangle. And we know that its length is 16. And because it's an equilateral triangle, every length is 16. And we know that the area of any triangle is 1/2 the base times the height. And remember that the base is one of the side lengths, so no matter which side length you pick, you're going to get 16. And so the trick here is to try and figure out what is the height of this thing. So it doesn't matter which side length you pick for the base, remember. So I'm just going to pick this horizontal one right here. and I'm going to draw a 90-degree angle in there, and somehow we're supposed to figure out the height. Now there are many different ways to figure out the height. Because the two remaining side lengths are equal, we know that this sort of half length right here must be equal to 1/2 of the side length, so this must be equal to 8. You have a 90-degree angle here, so we could also figure out this height by using the Pythagorean theorem. But I'm going to show you a more mature solution, a faster solution, provided you understand geometric theorems, and this goes back a while. So because the big triangle is equilateral, it is also equiangular. So this angle here is 60 degrees. This angle here is 60 degrees. And I won't draw it in, but the big angle down here is also 60 degrees. Now if we just look at this blue triangle here, this right triangle, you have an angle that's 60, an angle that's 90, and so the last angle in here must be 30 degrees. And I'll name this little triangle ABC. You can see from our picture that triangle ABC is a special triangle. It is a 30, 60, 90 triangle. So if you recall, in a 30, 60, 90 triangle, let's say this is 30, this is 60, and this is 90, this is A. The shortest leg is 1/2 the hypotenuse, and the longer leg is the square root of 3 times the shorter leg. So I went through that quite quickly because the understanding here, or the assumption here, is that you understand the 30, 60, 90 theorem. If you don't understand this theorem, I highly recommend you look back at some of the notes in Unit 7 that discusses this very important theorem. And with this theorem in mind, we can answer this question quite quickly. Because we know that the shortest leg is 8, the longer leg here must be 8√3. Okay, so in other words, the height of this triangle must be 8√3. So we can take this piece of information and use it in our problem. So we have area is equal to 1/2 multiplied by 16 multiplied by the height, which we had already figured out is 8 times the square root of 3. So put it all together, 1/2 times 16 is 8. We still have 8 times the square root of 3. So this gives us 64 times the square root of 3. And that is our final answer, the area of this triangle in simplest radical form. And I want to stress one thing here is that you may think this problem at first seems impossible. There's very little information that's given, but it is totally solvable. And not only that, it is totally solvable without touching a calculator. We do some very basic mathematics like 1/2 times an even number, and we know from previous theorems that this middle length here must be a specific value, and we don't have to invest too much of our energies into doing complicated calculations. All right, so that is all. That concludes the notes on this section that deals with areas of triangles and parallelograms, and you've seen hopefully enough examples from the simplest to the more difficult and more challenging. As always, ask for help if you need it. Thank you for watching and have a wonderful day.